A very good morning to all. This is P. Kavika, working as an assistant professor at RMD Engineering College in Triplet Department. And now we will see the 80, 85 ascending and descending order programs. So first one in the ascending order, we are supposed to arrange the numbers from the smallest towards the largest. So with the given set of data, we'll have to sort the numbers from the smallest towards the largest number, for which we will require two different types of counters. So first one is the outer counter and the second one is the inner counter. The outer counter is the total number of processes and the inner counter is the comparing of the datas. So the counter value will always be equal to total number of datas minus 1. So for a sample of 5 datas given, the counter value will be 5 minus 1, which is equal to 4. So initially the outer counter will hold the value 4 and the inner counter will also hold the value 4. So in case of the inner counter, the first and the second value being compared is C is equal to 0, 4. And then comparing the second and third value, the C value will get decremented to C is equal to 0, 3. And then the C value will again get decremented to 2, where the third value will be compared to the fourth value. And then the C value will further get decremented to 0, 1, where the fourth and fifth value will be compared. And then C value will be equal to 1. So again, once the entire process is over, we will start to decrement the outer counter value, which is the outer counter, which is from 0, 4, or it will be decremented to 0, 3, 0, 2, 0, 1 and 0. And what happens is, while comparing these values, compared, always the first value should be less than the second value. If the first value is less than the second value, then the process will move on to comparing the consecutive values. If in case, for example, over here in the 410015, which is greater than 4101 value, which is 5. So what will happen is, if in case the first value is greater than the second value, there will be swapping of numbers taking place, or these numbers will get interchanged. So this 5 will move on to the memory location 4100 and 15 will move on to location 4101, which is called as swapping or interchanging of numbers. And then we will decrement the inner counter value and we will compare the second and the third value. And the process will go on. Since the total number of data we have taken here for sample is equal to 5, the counter value will be equal to total number of data minus 1, which is 5 minus 1 equal to 4. So initially we are taking the B register value to be equal to 0, 4, which is assigned to the outer counter. And the C register value is also taken as 0, 4, which is assigned to be the inner counter. So initially we are taking the numbers as it is. So 4100 location has got 15, 4101 has got 5, 4102 is 25, 4103 is 10, 4104 is 20. So first what we will do is we will assign the first memory location so that the accumulator will hold the value 15. And the second memory location value is assigned to the D register. So D is equal to 15. On comparing these two data, what happens is, it is found that the accumulator data is greater than the D register data. So the swapping of numbers will take place. So what happens is 4100 will now hold the value 5 and 4101 will start to have the value 15. And the remaining numbers will all be the same. The consecutive remaining numbers will be as it is. And this process which we have done now is for the inner counter value, which is equal to 0, 4. Next, what we will do is we will decrement the C register value to 0, 3, and then we will start comparing the second data with the third data. So the first data has been interchanged to 4100 equal to 5. Next, the 4101 is equal to 15 and 4102 is equal to 25. So this first data has been assigned to the accumulator and the second data has been assigned to the D register value. On comparing these two numbers, the accumulator is found to have a number which is less than the D register value. So no swapping of numbers will take place. There is no need for any rearranging of numbers. Since the accumulator value is the lesser value, the numbers order will remain as it is. So 4100 is equal to 5, 4101 is equal to 15, 4102 is 25, 4103 is 10 and 4104 is 20. So now for C is equal to 3, we've done the comparison of the numbers 2 and 3. Next, we will decrement the C register value to be equal to 2 and we will compare the third and the fourth value. So the third value will be assigned to the accumulator and the fourth value will be assigned to the D register. On comparing these two values, we get to know that the accumulator value is the highest compared to the D register value. So swapping is required to change the order into ascending order. So once when we swap the numbers, what happens is 10 will shift to the accumulator and 25 will move on to the D register. So 410000 will hold the value 5 as it is in the previous step, and 4101 will also hold the value 15, which is already mentioned in the previous step. Only the 4102 and 4103 are over here interchanged. So 4102 will be equal to 10 and 4103 will be equal to 25, and the last memory location value 4104 will remain as it is as 20. Next, what we will do is we will decrement the C register value further to be equal to 0, 1. On decrementing it once, next we will have to compare the fourth data with the fifth data. So the accumulator is assigned with the value 25 and the D register is assigned with the value 20. Since the accumulator value was greater than the D register value, here interchanging or swapping of numbers is required. So the first three data will remain as it is. The fourth and the fifth data will get interchanged compared to the previous step. So 41005, 4101 is 15, 4102 is 10, 4103 is now 20, and 4104 is now 25. Only these two numbers have been interchanged compared to the previous step. And now when we decrement the C register value, C register becomes 00. So once the C register has reached the value 0, next what we will do is we will decrement the B register value by one step. So now the B register will hold the value 03. And when B register is equal to 03, again C will be equal to 04, which is the total number of data minus 1, which is equal to 04. Again, we will copy all the numbers from the previous step, and then the process will carry forwarded. So now again the first two data will be compared, and then the second and third data will be compared, then the third and fourth data will be compared, after which the fourth and fifth data will be compared. So for C is equal to 04, as usual, we will compare the first two datas. Now the first data accumulator is assigned with the first data, which is 5, and the D register is assigned with the second data, 15. Since the accumulator data is less than the D register value, no swapping is required, and the numbers order will remain as it is from the previous step. After which we will decrement the C register value to be equal to 03. In the previous step, C is equal to 04. Now on decrementing, we will get C is equal to 03. So now in C is equal to 03, we will be comparing the second data with the third data. So this 4101 value 15 is assigned to accumulator, and 4102 10 is assigned to the D register. Since the accumulator value is greater than the D register value, here swapping of numbers is required. So on swapping, what happens is 4100 will hold the same value 5, and 4101 will be assigned with 10 now, which is the swapping of numbers, and 4102 will be interchanged with 15. And the remaining fourth and the fifth data will remain as it is. And after which what we will do is we will further decrement the C register value to be 02, and again the third and the fourth data will be compared. After which the C register will be further decremented to compare the fourth and the fifth data. And again we will decrement the B register, and already we have the numbers arranged in ascending order in this step itself. So after the process is complete, 4100 holds the value 5, 4101 is 10, 4102 is 15, 4103 is 20, and 4104 is 25. So we have now got the values arranged in from the smallest towards the largest, which is in the ascending order. Next, we will look at the program. To explain the coding, first MVI B,04. So what we are doing is we are assigning the B register value to be equal to 04, because the total number of sample data that we are taking is equal to 5. So the outer counter value will be equal to total number of data minus 1. So MVI is assigned the value B is equal to 04. And then LXI H, 4100, where we are initializing the first memory location to be 4100. And then MVI C, 04, which is the inner register. So the outer register value and the inner register value will have to be the same as total number of data minus 1, which that is why C register is also assigned with the value 04. Next, what we do is move A, M. So move A, M, we are transferring the first data to the accumulator. So the first memory location data is 4100, and that data has been assigned to the accumulator. And then what we do is increment H. When we increment the memory location from 4100, the memory location has been incremented to 4101. And now we are comparing the memory location data along with the accumulator data. That is why CMPM. We are comparing the memory location data and the accumulator data. So the first data which we've taken is 15, and the second data which we've taken is 5. So the memory location is holding the value 5 and the accumulator is holding the value 15. If the accumulator data is less than the memory location data, then the condition will, yes. When comparing the memory location data and the accumulator data over here, what happens is if A is less than M, then it will move on to loop 1. If the accumulator data is less than the memory location data, it will jump. But over here, the accumulator data is equal to 15 and the memory location data value is equal to D comma M. Since the accumulator value is greater, change the numbers in order to change the numbers in the order. So first what we do is we are moving the move D comma M. The memory location data value has been transferred temporarily to the D register. So the memory location value 5 has been transferred to the D register and accumulator value is moved on to the memory location. Accumulator is having the value 15, which is now moved on to the memory location, which is in 4101. And then what we do is in the memory location, we have the value 15. And the memory location value, it is moving on to the current memory location, which is 4100. And then what happens is move M comma D. Now D is having the value 5. So that value 5 will be shifted on to the memory location 4100 and then increment H. So from 4100 memory location, we are again incrementing the memory location to 4101, which means what we have done so far is um, we have actually compared the data of 4100 along with 4101. We've compared the data, and since the first data was greater than the second data, we have actually swapped the numbers. And now we will decrement C. C was initially C is equal to 0.4, and on decrementing C, it will become equal to 0.3. So on decrementing C, the entire process will again carry forward. The second and the third number will be compared, third and fourth number will be compared, fourth and fifth number will be compared. So on decrementing C, jump on no 0 to loop 2. If the C value is not equal to 0, again it will jump on no 0, it will move on to loop 2, which is over here. This is loop 2. So from loop 2, again the second and the third data will be compared and then it will be incremented. It will, after comparison, if the accumulator data is less, it will go on as it is. If the accumulator data is greater than the memory location data, interchanging or swapping of numbers will take place. And then it will go on comparing the third with the fourth number and then the fourth with the fifth number. So after this comparison, after this entire process is completed once, then we will decrement the B register value to be 0.3, because initially the B register value was equal to 0.4 and now it has been decremented to 0.3. Since the B register value is not equal to 0, it will move on to loop 3. Loop 3 is right from the beginning again. So from the first number, the second stage of processing will take place. Again, the first and the second number will be compared, second and third number will be compared, third and fourth, and then fifth, fourth and fifth will be compared. So that the smallest numbers will and the largest numbers will automatically get rearranged according to the ascending order. So once this entire process is complete and once the B register value also equals to 0, and then the program will come to an end. So on simulating this coding in the 8085 HSIM simulator, I have typed the coding over here in the editor page, and then we'll have to click on this assemble. So once we click on assemble over here, it will show us if in case there are any errors in the program. So before which we will have to enter the data 4100 equal to 15, 4101 equal to 5, 4102 which is equal to 25, 4103, which is equal to 10, and then 4104, which is equal to 20. So after giving all these numbers, input data, I'm giving run all at a time. And now what happens is all the values have been sorted in ascending order. So now the values are 5, 10, 15, 20, and 25, which is all being arranged in ascending order. And the only difference between the ascending order and descending order program is there is change in the coding. If there is a carry, then it will move on to loop 1. Over here, if there is no carry, then it will move on to loop 1. That is the only difference between these two coding. So what is mentioned here is if A is greater than M, then go on to loop 1. Since it is descending order, we will be sorting the numbers from the largest towards the smallest, for which we require jump on no carry. In case of ascending order, we will have JC, which is jump on carry. That is the only difference between these two codings. Thank you.